I'm Dr. Prashant Jaikumar, and I'm a theoretical astrophysicist here in the physics department at Cal State Long Beach. I study the life cycle of stars, like our sun, but also stars which are very different than our sun. I guess my fascination with astronomy and astrophysics began when I was just a kid. My dad bought me my first pair of binoculars, much like this one, and I used to love staying up late at night, waiting for the stars to come out. Eventually, I got my first telescope, and I was simply blown away the first time I could see the rings of Saturn, the moons of Jupiter, the craters on the moon. For me, this was a personal discovery at a very young age that I'm part of a much bigger world, a much grander existence. I guess this early experience is what really pulled me into physics. The feeling that you could understand what was happening far away in outer space if you could just understand the things happening all around you in daily life. For example, the same force that keeps our feet on the ground, gravity, also makes this tiny pebble fall to the ground, and also keeps the moon in orbit around the Earth. I chose to study physics because I wanted to explore and learn more about such connections to the outside world. And there were practical reasons too. A physics degree is a great way to get ahead in life, with meaningful job opportunities and a rewarding career. I did my PhD at Stony Brook University, a great place. You could study all kinds of physics there. I chose to study what happens to really big stars when they explode as a supernova. Now, our sun is just an average-sized star, a hot and dense ball of hydrogen and helium, where the hydrogen fuses to form helium and releases a tremendous amount of energy that makes life on Earth as we know it possible. Eventually, though, the sun will run out of its hydrogen fuel and will ultimately fade away to form a tiny star called a white dwarf. I'm interested in the life cycle of stars that are 10 times bigger than our sun. What happens to them when they run out of fuel? Well, turns out they don't go quietly. They explode as a gigantic supernova. Most of the star gets obliterated, but a tiny piece gets left behind. That's called a neutron star. What makes neutron stars so special is that they contain forms of matter inside them that you will never find anywhere here on Earth. No one really knows what's inside a neutron star, and that's what I want to discover. With my collaborator, Dr. Rashid Uyed at the University of Calgary in Canada, we proposed a model, the quark nova model, to answer some very fundamental questions associated with neutron stars and the creation of elements. How and where did the elements like gold, silver, and copper get made? Turns out the answer is hidden in the guts of a supernova. Did you ever wonder where gold comes from? You might be thinking, gold comes from gold mines, or miners pan for gold in rivers, but how did the gold get there in the first place? In fact, our sun and all the planets arose from the ashes of a nearby supernova explosion that happened a long, long time ago. Current models suggest that the gold we find on Earth today was also created in the supernova explosion. With my collaborator, Dr. Rashid Uyed, we proposed a different pathway for the creation of elements, the quark nova model. Here, the elements are created when an explosion happens inside a neutron star. My research here at CSULB is aimed towards developing the theoretical basis for the quark nova model and checking against astrophysical evidence. It's an exciting process of learning and discovery, and it's what makes physics a fulfilling quest for me. That's why I enjoy teaching and working here with my students at Cal State Long Beach. I find that I understand things better when I have to explain them to my students. I find it very satisfying when my students appreciate these new scientific ideas and go on to explore ideas of their own. At Cal State Long Beach, I have this wonderful opportunity to teach, to work, and most importantly, to never stop learning. I hope you too will want to be part of such a great place.